What you are looking at is what is known as some will call the periodic table, right? Each one of these atoms are a chemical element, including oxygen. This is a chemical element. All right, so this is from ptable.com. We're going to actually read together, so you don't have to take my word. So we're going to start right over here. What is matter in science definition? So it's very important to read the scientific definitions of words. In science, matter is the term for any type of material. Matter is anything that has mass and takes up space. At a minimum, matter requires at least one subatomic particle, although most matter consists of atoms. The word matter is sometimes used to refer to a pure substance. We'll touch on that later. What is a chemical element? A chemical element or an element is defined as a material which cannot be broken down or changed. That's very important to understand. It's an element that cannot be, well, it's defined as a material which cannot be broken down or changed into another substance using chemical means. Elements may be thought of as the basic chemical building blocks of matter. There are 118 known elements. What is an atom? An atom is a fundamental piece of matter. An atom itself is made up of three tiny kinds of particles, which is called subatomic particles. Protons, neutrons, and electrons. The protons and the neutrons make up the center of the atom. So the center of the atom is made up by protons and neutrons, and it's called the nucleus. And the electrons fly around above the nucleus in a small cloud. The nucleus is the positively charged central core of an atom, consisting of protons and neutrons and containing nearly all its mass. All right. Nucleon. What is a nucleon? In physics and chemistry, a nucleon refers to any subatomic particle found in the nucleus of an atom. So what's found in the nucleus? Protons and neutrons. All right. For instance, protons and neutrons are nucleons, since they are in the nucleus of the atom. Nucleons are made of quarks. Go into that later or another time. So what is a proton? A stable, keyword stable, subatomic particle occurring in all atomic nuclei with a positive electric charge equal in magnitude to that of an electron, but of the opposite sign. Okay, so protons have a positive electric charge. Electrons are also a stable subatomic particle with a charge of negative electricity, found in all atoms and acting as the primary carrier of electricity in solids. Next is neutron. Neutron is a subatomic particle of about the same mass as a proton, but without an electric charge, present in all atomic nuclei except those of ordinary hydrogen. Right, hydrogen has no neutrons. Okay, so now we are at the electromagnetic force. It's a force of attraction or repulsion. So it can repel or attract. Okay, so it's a force. It's an electromagnetic force that can repel or attract. That's important. Between all electrically charged particles. Which ones are charged? Protons and electrons. Okay, so this electromagnetic force is either going to repel electrical charged particles or attract them. Protons are found inside the nucleus at the center of the atom, and they give the nucleus a positive charge. Okay. The neutrons are also in the nucleus, but they don't have an electron. They do not have an electric charge at all. So of course, the electrons and the protons, they attract each other and they repel each other. Protons repel protons, repels electrons, but they attract each other. The nuclear force, okay, is a force that acts between the protons and neutrons of atoms. Neutrons and protons, both nucleons, so they both are nucleons, are affected by the nuclear force almost identically. Since protons have a +1 charge, electrical charge, they experience an electric force that tends to push them apart. That's the repulsion we talked about. But at short range, the attractive nuclear force is strong enough to overcome the electromagnetic force. The nuclear force binds nucleons into atomic nuclei. Okay, so the nuclear force overpowers the electromagnetic force, keeping the protons together from repelling. Okay. So chemical elements constitute all, here we go. Chemical elements constitute all of the ordinary matter of the universe. However, astronomical observations suggest that ordinary observable matter makes up only 15% of the matter in the universe. The remainder is dark matter. The composition of this is unknown. The composition of dark matter is unknown, but it is not composed of chemical elements. Okay? So dark matter is not composed of chemical elements. It will not be on your chemical periodic chart. Okay, so now when we talk about the 118 elements on your periodic chart, we must talk about what is a synthetic element. So it says a synthetic element is one of 24 chemical elements that do not occur naturally on Earth. They have been created by human manipulation of fundamental particles in a nuclear reactor or particle accelerator, or explosion of an atom bomb. Thus, they are called synthetic, artificial, or man-made. So now, which elements are these? So there will be no confusion in the chat. We don't got to guess. It tells us which ones are man-made or synthetic, okay? The synthetic elements are those with the atomic numbers 95 to 118. I will explain what atomic numbers are later, okay? So it says as shown in, well, yeah, different colors. Watch this. Let me go down. So 7 other elements that were created artificially and thus initially considered to be synthetic were later discovered to exist in nature in trace quantities. So 7 other elements that was thought to be considered synthetic, man-made, only man-made, has been later discovered to exist in nature in trace quantities. Scientists predict things. The first is technetium. It was created in 1937, right? Plutonium, atomic number 94, first synthesized in 1940, is another such element, all right? So, but these later on were found to occur in nature. So these won't fit the artificial or man-made atomic numbers 95 through 118. So there'll be no confusion, 95 through 118 only. All right, so what you're looking at right now is an atom, okay? And we're looking at the number 8. So let's go back to the periodic chart. So when you go to this beautiful chart, you're gonna see a whole bunch of letters and numbers and names, okay? So you got boron, number 5 above it, got the letter B, you got the name boron, and you got 10.81. So I'm going to attempt to explain that for those who might have forgotten or those who never knew. Okay, so the number 8 represents the atomic number. That is the total number of protons within that atom, within that nucleus. The symbol is O. So for oxygen, it's the symbol is O. Now you can never guess in advance the symbol. So these are really, you got to just memorize these. All right, then it has the name, and then it has the atomic mass at the bottom, which is going to round off to 16. So the atomic mass is just simply the total number of protons and the total number of neutrons combined. In a neutral atom, they will be the same number. The electrons will also be the same number as the protons in a neutral atom. So you got 888. We don't, as you notice that the number of electrons are not here because it's automatically assumed that the electron number count is the same as the proton number count. So oxygen is 888. 8 protons, 8 electrons, and 8 neutrons. This is a neutral atom, right? Let's go further. So here we go. Let's get more in depth. So this is an atom of helium. And we're looking at the atomic number or proton number, usually represented as Z, right? So it's number 2. That means 2 protons. Then we have the actual symbol. So the name is not spelled out this time. Okay, so this is helium, He. Again, you got to memorize this stuff. There's no way to figure out in advance what the symbols are. And you can't use logic. Okay, because iron, what is iron? You would think it's something with an I, right? Wrong. It's Fe. So the atomic mass is 4. So here we go. This is the actual depiction of an atom. So we have the 2 electrons. This is a neutral atom. 2 electrons in green. We have 2 protons representing pink. So you see the charges, the minus charge, negative charge, the positive charge, and we have no charge, which is neutrons. So this is a neutral atom, 222. All right, 2 electrons, 2 neutrons, 2 protons, and atomic mass is the protons and neutrons together counted. So now let's go to isotopes, okay? What are isotopes? Isotopes differ, it's the same atom, okay? That means they got the same proton count. They just differ in neutrons, right? So right here we have hydrogen with a proton, no neutrons, but it's definitely an electron, the same number of counts, protons. So it's 1, 1, 1 proton, 1 electron. The atomic mass is 1 because we have 1 proton. All right. So if you look over here, we all of a sudden have a neutron. So this is still hydrogen because the proton number count is still 1. As long as the proton number count stays the same, you are dealing with the same atom. It doesn't matter how many neutrons come into that nucleus. It's just called an isotope. So now we have what? The atomic mass is 2. All you do is combine the number of protons with neutrons, and we have 2. Okay, so this is an isotope. We have 1 proton still, so we're still dealing with hydrogen, and now we have 2 neutrons. So we add those together, and that's your atomic mass, all right, which is 3. So these 2 are the isotopes of this. This is the original, and these are isotopes. So as long as the proton count is the same, it's the same element. It doesn't matter how many neutrons you have. You can have less. It's still an isotope of that particular atom. You can have more. It's still an isotope of that particular atom, meaning that it's still that atom, whatever it is. Okay, so here's a larger depiction of isotopes. So we have 1 proton. Remember, in a neutral atom, we assume the number of protons is equal to the number of electrons. So we have 1 proton, 1 electron. We just added in a neutron. So this is a isotope of hydrogen. Now the atomic mass increases. So the atom gets heavier or lighter depending upon how many neutrons are involved. But it's still hydrogen. It doesn't affect or change the element. It will always be hydrogen. Now, if their proton count changes, you got a different, that's no longer hydrogen. So if another proton comes in here, you are now dealing with helium. Here we go again. So as you can see, you have carbon, 666, 667. Remember, the neutron number changes, but the proton and the electron number stays the same. So it's 667. This is 668. Carbon 14, carbon 13, and this is just carbon. So now you see when you have carbon 13, You know that regular carbon is 12. So 13 just tells you that there's one more neutron. If it's 27, that means just 15 more neutrons, if that's even possible. And that's it. Quick lesson on what a chemical element actually is. It's everything on that periodic chart. They are all chemicals, okay?